Exercise 1.2, question number 9, Roman 9, y equal to sin inverse of 1 minus 25x square upon 1 plus 25x square. In place of this 25x square, we can have here 5x bracket square, because 5x bracket square is 25x square. If we put in place of this 5x tan theta, then we can have 1 minus tan square theta upon 1 plus tan square theta. So 1 minus tan square upon 1 plus tan square theta can give you cos of double of theta. We can have this cos 2 theta as sin 90 minus 2 theta. Okay, cos 2 theta as sin 90 minus 2 theta, because cos A is always sin 90 minus A. Sin inverse of sine of any angle is that angle only. Therefore, y will become pi by 2 minus 2 theta. By resubstituting this theta, what is theta here? As 5x equal to tan theta, then theta is tan inverse of 5x. So, then y equal to pi by 2 minus 2 times theta is tan inverse of 5x. Differentiating with respect to x, derivative of this constant is 0, and this minus 2 along with variable as it is, derivative of tan inverse of 5x is 1 upon 1 plus 5x square, because derivative of tan inverse of x is 1 upon 1 plus x square. Derivative of tan inverse of 5x is 1 upon 1 plus 5x bracket square. Into derivative of this 5x is 5. So final answer is minus 10 upon 1 plus, what is square of this? It is 25x square. Roman 10, y equal to sin inverse of 1 minus x cube upon 1 plus x cube. That is sin inverse of 1 minus x raised to 3 by 2 raised to 2. We can have power raised to power as product of powers. Therefore, 3 by 2 into 2, that is 3. Therefore, we can have this x raised to 3 as x raised to 3 by 2 raised to 2. Now we can put in place of this x raised to 3 by 2 tan theta. It will give you sin inverse of 1 minus tan square theta upon 1 plus tan square theta. 1 minus tan square theta upon 1 plus tan square theta is always cos 2 theta. Therefore, y equal to sin inverse of cos 2 theta now. We can have this cos 2 theta as sin 90 minus 2 theta, because cos A is sin 90 minus A. Sin inverse of sine of any angle is that angle only. So y will become now pi by 2 minus 2 theta. By resubstituting the value of theta, what is the value of theta here? We have placed x raised to 3 by 2 as tan theta. Therefore, theta is tan inverse of x raised to 3 by 2. So y will become pi by 2 minus 2 tan inverse of x raised to 3 by 2. The constant pi by 2 derivative of that is 0. Minus 2, the constant along with variable as it is. So minus 2 will remain as it is. Derivative of tan inverse of x is 1 upon 1 plus x square. Therefore, derivative of x raised to 3 by 2 will be 1 upon 1 plus x raised to 3 by 2 square. Into derivative of this x raised to 3 by 2, it will be 3 by 2, power will come down, 3 by 2, x raised to, this power will get decreased by 1, 3 by 2 minus 1 will give you 1 half. Let us see. See here, same thing, derivative of pi by 2 is 0, okay, minus 2, constant along with variable as it is, and derivative of tan inverse is 1 upon 1 plus x square. Therefore, derivative of x raised to 3 by 2, here it is 1 upon 1 plus x raised to 3 by 2 square. Derivative of x raised to 3 by 2 is 3 by 2 x raised to half. So this 2 and 2 will get cancelled. So final answer is minus 3. This x raised to half means root x upon 1 plus x raised to 3 by 2 raised to 2 will give you x cube. Next question, Roman 11, y equal to tan inverse of 2x raised to 5 by 2 upon 1 minus x raised to 5. We can have this x raised to 5 as x raised to 5 by 2 bracket square, because x raised to 5 by 2 raised to 2, then power raised to power, we can multiply these powers. 5 by 2 into 2 will give you 5 again. Now in place of this x raised to 5 by 2, we will put tan theta. It will give you 2 tan theta upon 1 minus tan square theta. We know that 2 tan theta upon 1 minus tan square theta. See here, 2 theta upon 1 minus tan square theta is tan 2 theta. So here also 2 tan theta upon 1 minus tan square theta is tan of 2 theta. So y will become now tan inverse of tan of 2 theta. Tan inverse of tan of any angle is that angle only. Therefore, tan inverse of tan of 2 theta is 2 theta. What is the value of theta? Theta is tan inverse of x raised to 5 by 2, because tan theta is x raised to 5 by 2. Theta is tan inverse of x raised to 5 by 2. So y will become 2 into tan inverse of x raised to 5 by 2. Now differentiating with respect to x, derivative of y is dy by dx, to constant along with variable as it is. Derivative of tan inverse is 1 upon 1 plus that thing square into derivative of this angle x raised to 5 by 2 as 5 by 2 x raised to, the power will get decreased by 1, that will be 3 by 2. This 2 and this 2 will get cancelled. So final answer is x raised to 3 by 2 into this 5 upon 1 plus x raised to 5. Okay, 5 by 2 raised to 2 will be x raised to 5 only. See. Now this x raised to 3 by 2, once again I will say x raised to 3 by 2, we can interpret it as x into root x. See here, x into root x. Roman 12, y equal to cot inverse of 1 minus root x upon 1 plus root x. Cot inverse of any angle is tan inverse of a reciprocal of that angle. So this is of the type tan inverse of a plus b upon 1 minus ab. Okay, we know that tan inverse of a plus b upon 1 minus ab is tan inverse of a plus tan inverse of b. Therefore here tan inverse of 1 plus root x upon 1 minus 1 into root x will give you tan inverse of 1 plus tan inverse of root x. See here. Now differentiating with respect to x, derivative of y is dy by dx. Derivative of this constant thing is 0. Derivative of tan inverse of x is 1 upon 1 plus x square. Therefore derivative of tan inverse of root x is 1 upon 1 plus root x square into derivative of this root x is 1 upon 2 root x. So final answer is this 1 upon 2 root x, 1 plus, what is the square of root x? Square of root x is x. Roman 12, final answer is 1 upon 2 root x upon 1 plus x. Sorry, 1 upon 2 root x in bracket 1 plus x. Question number 10 now. Differentiate with respect to x, y equal to tan inverse of 8x upon 1 minus 15x square. We can have this 8x as 5x plus 3x and this 15x square as 5x into 3x. So 5x plus 3x 8x and 5x into 3x is 15x square. This is of the type tan inverse of a plus b upon 1 minus ab. That will be tan inverse of a plus tan inverse of b. That means here tan inverse of 5x plus tan inverse of 3x. Now differentiating with respect to x, Derivative of y is dy by dx. Derivative of tan inverse of x is 1 upon 1 plus x square. Therefore, derivative of tan inverse of 5x will be 1 upon 1 plus 5x square into derivative of this 5x is 5. Derivative of this tan inverse of 3x will be 1 upon 1 plus 3x square, that is 1 upon 1 plus 9x square it will be, and derivative of this 3x is 3. Okay, so final answer is 5 upon 1 plus 25x square plus 3 upon 1 plus 9x square. Roman 2, y equal to cot inverse of the angle. We know that cot inverse of the angle is tan inverse of reciprocal of that angle. Now, this 2x we can have it as 7x minus 5x. Okay, 2x is nothing but 7x minus 5x, and this 35x square as 7x into 5x. So, see here 7x minus 5x, the numerator 2x as it is, and 1 plus this 7x into 5x, 35x square, denominator also as it is. So we can write this 2x upon 1 plus 35x square as 7x minus 5x upon 1 plus 7x into 5x. This is of the type tan inverse of a minus b upon 1 plus ab now. Okay, so it will give you tan inverse of a minus tan inverse of b. That is tan inverse of 7x minus tan inverse of 5x. Derivative of tan inverse of 7x will be 1 upon 1 plus 7x square into derivative of 7x will give you this 7. Derivative of tan inverse is 1 upon 1 tan inverse of 5x. Derivative of tan inverse of 5x will be 1 upon 1 plus 5x bracket square into derivative of this 5x will give you 5. So final answer is 7 upon 1 plus 49x square minus 5 upon 1 plus 25x square. Roman 3, y equal to tan inverse of 2 root x upon 1 plus 3x. That is equal to tan inverse of this 2 root x, we can have it as 3 root x minus 1 root x. 3a minus 1a is 2a. Also, this 3 root x into 1 root x can give you 3x. So, this 3x can be written as 3 root x into 1 root x. This is of the type tan inverse of a minus b upon 1 plus ab. That means tan inverse of a minus tan inverse of b. Here it will be tan inverse of 3 root x minus tan inverse of 1 root x. Differentiating now with respect to x, derivative of tan inverse of 3 root x will be 1 upon 1 plus 3 root x bracket square. Because we know that tan inverse of derivative of tan inverse of x is 1 upon 1 plus x square. Therefore, tan inverse of 3 root x is 1 upon 1 plus 3 root x square into derivative of this 3 root x minus tan inverse derivative of that is 1 upon 1 plus the angle is root x here. So, it will be 1 upon 1 plus root x square into derivative of this root x is 1 upon 2 root x here. Here also the derivative of root x is 1 upon 2 root x. This 3 along with variable is as it is. Now we can have this 1 upon 2 root x common. So 1 upon 2 root x in bracket 1 upon 1 plus 9x minus 1 upon 1 plus x. We can simplify this by cross multiplication and we can have the final answer as 1 upon root x in bracket 1 minus 3x upon 1 plus 9x into 1 plus x. This is the final answer. You can write this as final answer also. Okay. Now Roman 4, y equal to tan inverse of 2 raised to x plus 2 upon 1 minus 3 times 4 raised to x. This 2 raised to x plus 2 we can have it as 2 raised to x into 2 raised to 2. We know that in multiplication, addition of the powers. So it will be 2 raised to x plus 2 as it is. This 2 raised to 2 is nothing but 4 into 2 raised to x. This 4 into 2 raised to x, we can write it as 4 minus 1. That means, 4 into 2 raised to x, we can write it as 3 plus 1. 3 into 2 raised to x plus 1 into 2 raised to x. 3a plus 1a is 4a. And this multiplication can give you, see here, 3 ones are 3 again, and 2 raised to x into 2 raised to x is 2 raised to x square. So we can interpret this bracket as 3 2 raised to x plus 1 2 raised to x upon 1 minus 3 2 raised to x into 1 2 raised to x. This is of the type tan inverse of a plus b upon 1 minus ab. That means tan inverse of a plus tan inverse of b. Here it will be tan inverse of 3 2 root x plus tan inverse of 1 2 root x. Derivative of tan inverse of x is 1 upon 1 plus x square. Here also derivative of tan inverse of this bracket is 1 upon 1 plus this bracket square into derivative of this bracket. Same thing here. Now we know that 3 square is 9. 2 raised to x square is 4 raised to x. See here, this 4 raised to x, how we are writing here 4 raised to x as 2 raised to x bracket square. Here is the expression. 4 raised to x is nothing but 2 raised to 2 raised to x. That means power raised to power, it is product of the powers, it will become 2 raised to 2x. We can have it as now 2 raised to x raised to 2. Once again, this multiplication can give you 2x because power raised to power is product of the powers. So we can have this 4 raised to x as 2 raised to x bracket square. So in the first step also we have written here 4 raised to x as 2 raised to x bracket square. And now for simplification we are writing here 2 raised to x bracket square as 4 raised to x. 3 constant along with a variable as it is, and derivative of a raised to x is a raised to x into log of a. So derivative of 2 raised to x will be 2 raised to x into log of 2. Here also 1 upon 1 plus 4 raised to x it will be, and derivative of 2 raised to x will be 2 raised to x into log of 2. This 2 raised to x log of 2 is common here. Whatever remain is in the bracket. Roman 5. Y equal to tan inverse of 2 raised to x upon 1 plus 2 raised to 2x plus 1. That is tan inverse of this denominator, we can write it as 1 plus this 2 raised to 2x plus 1. That is 2 into 2 raised to 2x. In multiplication, addition of the powers. So 1 plus 2x will give you 2x plus 1, that is 2 raised to 2x plus 1 we are writing here as 2 raised to 2x into 2 raised to 1. Now we can have this 2 raised to x as 2 into 2 raised to x minus 1 into 2 raised to x. That means 2a minus 1a is always 1a. And also this 2 into 2 raised to 2x, we can have it as 2 into 2 raised to x into 2 raised to x, because 2 ones are 2 here, and 2 raised to x into 2 raised to x is 2 raised to x bracket square. That will be 2 raised to 2x. Okay, see here 2a minus 1a is 1a, and this product I have written here, this product is giving you the same thing written here, that is 2 ones are 2 and 2 raised to x bracket square will give you 2 raised to 2x. This is of the type tan inverse of a minus b upon 1 plus ab. That means tan inverse of 2 into 2 raised to x minus tan inverse of 2 raised to x. Derivative of tan inverse 1 upon 1 plus x square. Therefore, derivative of 2 into 2 raised to x will give you 1 upon 1 plus 4 into 2 raised to x square. Into derivative of this 2 raised to x, 2 into 2 raised to x, 2 constant along with variable as it is. Derivative of 2 raised to x is 2 raised to x log of 2. Same thing here. We can have this derivative of tan inverse of 2 raised to x as 1 upon 1 plus 2 raised to x bracket square into derivative of this 2 raised to x is 2 raised to x log of 2. We can have this 2 raised to x log 2 common, and whatever remain it will be in the bracket as it is. Okay. Now question number 6. Y equal to cot inverse of a square minus 6x square upon 5ax. Cot inverse of angle is tan inverse of reciprocal of that angle. That means 5ax upon a square minus 6x square it will be. For the result we want here 1. Okay. So we will divide the numerator and the denominator by a square. By dividing here by a square, what we will get? 5x upon a, because a will get cancelled and 1a will remain in the denominator. By dividing here by a square, we will get 1 here, and here by dividing x a square, we will have 6x upon a bracket square. See here, this 5m or 5p, we can write it as 3m plus 2m. 5p, 3p plus 2p. Therefore, 5x upon a, 3x upon a plus 2x upon a, because 3 plus 2 is 5 and 3 plus 2 is 6 here. So, this 6x upon a can be written as 3x upon a into 2x upon a. This is of the type tan inverse of a plus b upon 1 minus ab. So here it will be tan inverse of 3x upon a plus tan inverse of 2x upon a. Now differentiating, we can have derivative of this tan inverse of this bracket as 1 upon 1 plus that bracket square into derivative of 3x by a as constant 3 by a as it is, and derivative of x is 1 here. Derivative of tan inverse here is, it is 1 upon 1 plus x square. That means derivative of tan inverse will be 1 upon 1 plus this bracket square into derivative of this 2x upon a is 2 by a. By multiplying the numerator and denominator by a square, we will have a square here, and multiplying here by a square, we will have 9x square.